All right, so we're going to start by just doing some review of what we covered last class. All right, so take a second and do these two practice problems for me. One's a multiplication problem, one's a division problem, and as always with every calculation in this course, you're going to give me the answer reported to the correct number of sig figs. Let's do this first one. So I'm going to punch it into my calculator. I'm going to write down what my calculator spits out. 0.3297228. Okay? Then I got to go back and apply my sig fig rules. Remember, for multiplication division, the only one that we've learned thus far, our rule is counting. You're going to go back and count the number of sig figs in each of your inputs. In this first one here, 0.56, how many sig figs do I have? Just two. Those leading zeros never count, right? So this one's only 2. And what about the 5.888? That one would be 4. So remember, whichever one of these numbers is fewer, that's how many sig figs your answer has. So now I'm going to take this number right here that my calculator gave me, and I'm going to round it to 2 sig figs. Okay? So I'm going to start counting from the leftmost sig fig. This one right here is my first one. That means that this 2 right here is where I'm rounding to. I'm going to look right next door at that 9. That means I'm rounding up. So my final answer is 0.33. Okay? For this next one here, everybody take a second and punch this into your calculator. I want to prove a point here about doing operations in scientific notation. Let's make sure we get the same thing. Okay, so what you should get is 451.916 and some change, all right? So if you instead got the 4, the 5, the 1, but your decimal point was in the wrong position, it's because we're dividing by this number in scientific notation, and we got to keep both the 1.2 and the 10 to the negative 1 underneath that divisor sign, okay? Which means that since we're dividing by this whole thing here, we have to put this in parentheses when we're punching it into our calculator. Otherwise, it will divide by the 1.1 and then multiply the whole thing by the 10 to the negative 1. We need that 10 to the negative 1 on the bottom of our divisor sign, okay? So just in general, when you're dividing by a number in scientific notation, put that number in parentheses, all right? And that'll get you that 451, okay? Cool, so then we're going to go back and apply our sig fig rules. I'm clearly not very creative because we also have 4 and 2, right? Remember, all of our digits in scientific notation are considered significant. So then how do I round this to 2 sig figs to this 5 place here? Is the answer 45? No, because 451.916 rounded is not going to be 45. That changes the number, right? Remember, that 4 has to remain in the hundreds place. that 5 has to remain in the tens place. So I'm just going to tack a 0 on the end. There's no decimal point in that number, so this is still only 2 sig figs. All right? But that is my final answer, 450. Cool? What's up?
For the first one, I got
0.33?
No,
3.3. 3.3.
Oh, shucks. Yeah, I have an extra 0 in here. My bad. I was just making sure y'all are paying attention. All right, hold up. Yeah, I mean, yes. The decimal point's going to be moved over 1. So 3.3, and there we go. My bad. Cool. All right. Not to be super confusing to start off the day here. Okay, anyways, we got a different set of rules to learn now, because now we have other operations to get to, specifically addition and subtraction. Okay? This is going to be a different set of rules for carrying sig figs. We really need to keep these in 2 different bins in our mind, how we approach these problems. Remember multiplication and division, we said it was about counting, right? That's the one word you want to have in your mind when you're doing multiplication and division. Okay? So, addition and subtraction. What are our sig fig rules? All right, so let's do a problem like 3.2 plus 46.998. All right, so this is our example problem here. Step 1, we're going to take these 2 numbers and we're going to line them up at the decimal. We're going to set up this problem just like you learned how to do all the way back in elementary school when you were first learning how to do math, where you're going to keep the 1s in the 1s place and the 10s in the 10s place. You're going to line up your 2 inputs at the decimal. All right, so specifically by that I mean I'm going to take my 3.2 and my 46.998, and I'm going to stack them up together such that they're lined up at the decimal. All right, now I'm going to do the math. Punch it into my calculator. So I punch this into my calculator, I get 50.198. Okay, now I'm going to mark the last sig fig. Oops. In each of these inputs. All right, so for the 3.2, my last sig fig is that 2. For the 46.998, that's got a bunch more sig figs, right? So the last one in that number is the 8. Okay? Whichever position is further to the left. So I'm going to look here. This is the position of the sig fig in my first number. This is the position of the sig fig in my second input. Whichever position is further to the left, that's the position we're going to round our answer to. All right, so if I can round it to the red or the blue? To the red, right? To the 10th place. Okay, so we line them up whichever one of our sig figs is further to the left, whichever position is further to the left, that's what we're going to round our answer to. Okay, so in this case, I'm going to round to this position right here. My final answer would be the 50.2. Okay, so we're going to mark the last sig fig in each input, and whichever input whichever position rather, is further to the left, that's what we round to. All right, so let's just do one more. Alright, so punch it in my calculator, I get 50.735. Okay, I'm going to mark my last sig fig in both numbers. And then I'm going to look at the position of these sig figs, and whichever one is further to the left, the larger position, that's what I'm going to round my answer to. So in this case, I'm going to round to that blue, the 10th place. And so I would get 50.7. Okay? Notice that my answer has more sig figs than my input did, right? 0.5 only has one sig fig. My final answer has these 3 sig figs. That is perfectly legal under our rules for addition and subtraction. That wouldn't have been the case for multiplication and division, but we got 2 different sets of rules. We got to keep them in separate bins in our mind how we approach these problems, okay? So multiplication division is all about what? What's the one thing you're going to keep in your mind? Counting, right? For this one, what's the one word you're going to keep in your mind for your sig fig rules of addition and subtraction? This is all about the position of those sig figs. All right, so if I'm going to sum this up in one word that I'm going to think of when I'm trying to remember my rules, it's about the position of those sig figs in your number. All right, so we talked about sig figs. Sig figs are going to be a fact of life in this course. Every single calculation that we're going to be doing, the last step is going to be worrying about those sig figs, okay? And the good news is, to be perfectly honest, we do so much more multiplication and division just by virtue of the math in the course than addition and subtraction. Fortunately, those are kind of the easier rules to remember, all right? But we want to get them down here early because, again, it's just going to be rinse and repeat from here on out. So we talked about sig figs. The next thing we got to talk about is units. All right, we've been playing with these naked numbers. They didn't have any units associated with them. But in chemistry, we're always talking about measurements. All of our units always have, all of our numbers always have units associated with them. Okay? So it's always like 5.2, well 5.2 what? And their units are going to depend on what quantity we're talking about, what exactly we're measuring. So in chemistry, as well as the rest of the frickin' world, we use the metric system. All right, so our units for distance are going to be those meters or kilometers, not the feet and the miles that we're sort of used to here in America. We use the metric system. It just makes more sense sort of quantitatively. All right, so introducing y'all to these units here, if we're talking about distance, we would use meters or some variation thereof. And we'll talk about what I mean by that. We have these little prefixes we can stick on front, like centimeter and kilometer, kilometer. We'll talk about those here in a second. The abbreviation for this particular unit is M. Little m, that's how we do. So for example, 5.2 little m, that would be 5.2 meters. Okay? Convention is to have a space between the numerical value and your units. Another big one that we like to measure a lot in chemistry is volume. All right, so when you're baking a cake or whatever, you get your quarter cup of oil. That's the volume of oil that you're using, okay? Again, we use the metric system, so instead of cups and gallons and stuff, we use liters. Liters have the units of capital L. Another big one in chemistry is mass. All right, this is a very convenient way to get a specific amount of substance. You go to your balance in the lab and you mass out 0.5 grams of sodium chloride or salt, for example. Right, so we deal with mass a lot as well. In the imperial system, we use pounds. In the metric system, they use grams. And grams have the abbreviation of little g. All right. This one won't come up too terribly much in this course, but it is an important one. It will come up a lot in the next section, in the next course, Chem 1B. But that is time. How long does it take for a reaction to occur, for example? The base units for these are seconds, and we abbreviate that with a little s. All right, and then the last one that we're going to see is temperature. Okay, there's two units that you'll see throughout this course. One of them is degrees Celsius. It's got this little not C. Okay, that is sort of the metric system equivalent of what we use here, Fahrenheit, right? They use Celsius. The other one, though, and this is very specific to science, but we use it for a very good reason, and we'll talk about that when we get to it, is Kelvin. This is a sort of unit of temperature that you only see in the science world, but it's got a really important purpose, so we'll see it a bunch. And the units for that is this K, uppercase K. All right, so we're always going to be talking about measurements. Those measurements will have different units on the end, and those units correspond to what it is that we're measuring, right? Are we talking about 5.2 grams or 5.2 meters? Okay, so when we're doing our calculations, how do we carry our units? Again, we're going to have different rules for multiplication and division versus addition and subtraction. Okay? In multiplication and division, our units carry. So what the heck do I mean by that? All right? So let's say that we take 5.2 centimeters times 2.5 grams. Okay? If we got a problem like this, the first thing that we're going to do is we're going to punch it into our calculator and see what our calculator spits out. In this case, my calculator spits out 13. The next thing we're going to do is what? We got to do it with all of our calculations. We just reviewed it. Sig figs. We're going to go back and apply our rule for sig figs. In this case, my two inputs both have 2. My answer also has 2, so I'm done. Okay? And then the last thing we're going to do is worry about our units. And again, our units for multiplication and division will carry. So what does that mean? Just like I punched into my calculator 5.2 times 2.5, I'm also going to look at these units and multiply them. Centimeters times grams. Those are my units at the end of this calculation. Centimeters times grams. Right? My units just carry. I treat them like variables in my problem. So what if we had instead, let's keep the numbers the same to make our lives a little bit easier. We'll do 5.2 centimeters times 2.5 centimeters. Those numbers are the same, so we obviously get 13 when we punch it into our calculator again. But now my units are going to be those centimeters times centimeters, which we would abbreviate as centimeters squared. But again, I'm just carrying my units. I'm combining them together. All right, so now what if I did something like 12.6 centimeters squared divided by 1.9 centimeters. Okay, everybody take this calculation. See if you can't give me the answer to the correct number of sig figs, and see if you can't figure out what our units are as well.
For the first one, is that the final answer, 13 centimeters?
Yep. And honestly, those units aren't real. That's like that calculation doesn't make any sense, but that's how we would do it. All we do is we combine our units together. And we will see some mixed units that do occur naturally and will come up in the course. All right, so I punched this into my calculator, 6.63157. Okay, I'm going to go back and apply my rules for sig figs. How many sig figs should my answer have? Just 2, so I'm going to round to this position here. Okay, and now I'm going to look at my units. I have centimeters squared divided by centimeters. Well, that's going to cancel out from the top and the bottom, right? Just like if I had A times B divided by A, that cancels out, right? Same thing with our units. Again, we treat them like variables. So this answer would have the final units of centimeters, so final answer rounded to the correct number of sig figs. Boom. Okay? And then let's just do one more here. What if we had, we'll keep the values the same, 12.6 grams divided by 1.9 liters. We get that same 6.6. But now what are my units? Grams over liters. Nothing canceled out, right? So I just combine everything together. Grams divided by liters, nothing cancels out, so my units are grams divided by liters. All right, so for multiplication and division, our units carry throughout our calculation. All right, so now for addition, subtraction. For addition and subtraction, it's a little bit more stringent in terms of what you can be adding or subtracting from one another. Your units must match. Okay? You cannot subtract grams from centimeters. It just doesn't make any sense at all. Okay? You can subtract centimeters from centimeters, but your units of your inputs, they have to match in order for that operation to make any sense. So if we took something like 5.2 minus, oh whoops, I guess we need units, centimeters minus 1.1 centimeters, we would do our sig figs, punch it into our calculator. If we're going to do our sig figs, we can line it up real quick. Subtracting. So which position is the sig fig in my answer going to be? Ones or tenths or hundredths? Tenths place, right? They both line up at the same, so I know I'm going to round to this position here. I guess this isn't too bad. We can do this in our head. 4.1. And the units are just going to be centimeters, right? They have to match in our inputs, and those are simply your units on the other side. You cannot have any mixed unit operations going on when it comes to addition and subtraction. All right, so let's do one more just for the sake of practice here, and especially practicing our rules for addition and subtraction sig figs. So I'm going to line these up. At the decimal. Okay, and even before I punch it into my calculator, I can see based on the position of these sig figs here, that my final answer is going to have to be rounded to the hundredths place, right? That position that's further to the left. So before I even punch it in, I know I'm going to round it here. But then let's punch it into our calculator. 6.637. And again, I'm rounding to that 3. So 6.64. And what are my units?
Grams.
Just grams, right? Okay, we're actually going to do one more here because it's a little bit, let's actually keep this up. It's a little bit of one that stumps people here. We're going to take 1,100 meters and we're going to add 0.01 meters. Alright, so this one's a little weird, but the correct answer here is just 1,100 meters. Okay? So, let's first sort of convince ourselves just based on our rules that that's the answer, and then we'll talk about it a little bit more. Why does that make sense? So I'm going to take my 1,100. There is no decimal explicitly written in this number, but I know that it's right here, right? That's where the decimal point lives. I'm going to take my 0.01, boom, all right, my sig fig in that bottom number is over here in the hundredths place. But where's the last sig fig in that 1,100? What position? The hundredths place, all right? There is no decimal in that number. Those trailing zeros do not count as sig figs. So, my position of this sig fig is that hundredths place. I'm going to punch it into my calculator. 1100.01, but I'm going to round to that position that's further to the left. So I'm going to round to this position right here. When I round to that hundredths place, that's how I get 1,100. All right, and that's really weird because it's like, well, that's what you started with, and then you added more to it. How do you get the exact same answer back? Remember that these sig figs, they have this meaning to them. We don't want to get lost in our rules here. There's a purpose behind those rules, right? And that is we don't want to overstate our confidence in a particular measurement. When we were talking before, I said the back wall there is like 30 feet away, right? Am I going to change my answer when I take this little tiny shuffle step forward? No, it's still about 30 away. That 30 was such a squishy number to begin with. This tiny little step that I made isn't going to change that, right? Same thing here, 1100, that's a really squishy big number. There's not a lot of confidence in that number. Could be, 1090, could be 1110, right? There's only confidence in that hundreds place. You then take that tiny, very precise distance and add it to it. It's not going to change our big squishy number, right? So that's how we get that same answer back out as our input. We're taking a number that is not a lot of confidence. We're adding something very small, something we're really confident in. Our answer has to be something we're not terribly confident with, right? We don't want to overstate our confidence when we report our answers. That's the whole purpose of these rules of carrying sig figures. Okay, cool. All right, so we got our sort of basics of our math that we're going to need down. We were sort of letting this live in this like symbology space here. Now we're going to go kind of more practical application, talking about unit conversions. What's up?
Will we be able to do another example like that one?
Of this one here?
Yeah.
Sure, it's anytime you take a big number and add or subtract something that's very small. This is going to give you the same value. All right, because again, we're going to follow our rules. We're going to line them up at the decimal. We can mark our sig fig in each of our inputs. And the position that's further to the left is still, in this case, that thousands place. So that's where my answer is going to be rounded to.
Excuse me, what if it become 9.03 instead of 0.02? Will this answer be the same?
Say that one more time.
Instead of 0.02, what if we put 9.02 in there? Is the answer change?
In this case, no, because that would still be only in that ones place, right? So this, if you punch this into your calculator, you would still get 9.02. So you're still rounding to that thousands place. This number on the bottom would have to be something like 1, there would have to be something in that thousands position for it to update that number. Okay. So we're going to talk about unit conversions here. Okay, and at some point we'll graduate to like how do we convert from pounds to grams, our imperial system to our metric system. Right now what we're going to worry about is just converting our metric prefixes. Okay, so these are what we call metric prefix conversions. Okay, so in our imperial system that we're used to, if we're talking about things that are really short, if I wanted to measure the length of this calculator, for example, I would use units of inches for something small. But if I'm going to talk about the distance to my house, I'm not going to talk about how far that away that is in inches, right? That's ridiculous. I'm going to use a larger unit for it. I'm going to use units of miles for larger distances. In the metric system, anytime they're talking about distance, they use the units of meters, okay? But what they do is they change these prefixes out front when they're talking about something small versus something large. So for example, if they were talking about a small distance, the length of my calculator here, they would use units of centimeters. They put this prefix on their centi, meaning we're going to talk about something small. And if they were talking about the distance to their house, they would use units of kilometers, where they stuck this prefix kilo on there, meaning talking about something that's large, okay? So just like we have in our unit system this sort of different units for talking about small stuff versus large stuff, and again, it's not very convenient to talk about something like distances to somebody's house in units of inches, right? I mean, you could, but it would be like, nobody knows how to deal with that number, right? We're more familiar with these units of miles. They have the same sort of thing here, but what they're changing is just the prefix on that unit of meters. Okay? So we're going to work on how we're going to convert from, for example, centimeters to kilometers. All right? This is going to be our first introduction to our constants page for this semester. All right? There's a lot of information here, and we're going to pick it apart sort of one by one. All right? So for right now, we are not worried about this whole thing over here. This isn't what we're working with right now. We'll graduate to that. All right? We're focused on this box right here, our prefixes. Okay? So this is the portion of our constants page we're going to learn how to use right now. All right? We can see that on the left-hand side, we have a bunch of these prefixes. So for example, centi. I think everybody's heard of centimeters before. Okay? This is this prefix centi. We use the letter C. All right? Then we have this value over here, 10 to the negative 2. Okay? So what is that telling me here? This is telling me, let me get rid of this. This is telling me that 1 centimeter, for example, is equal to 10 to the negative 2 meters. All right? Another one that we probably heard before, kilo for kilometer. We abbreviate that with this unit K. All right, and then we got that value next to it, 10 to the 3. So again, what is that telling me? 1 kilometer is the same as 10 to the 3 meters. Likewise, 1 kilogram is 10 to the 3 grams. 1 kilosecond is 10 to the 3 seconds, etc., etc. All right, you can change the unit on the back end depending on whether you're talking about distance or mass or time or volume. All right, but these prefixes, they have these set values associated with them. So again, a centi is 10 to the negative 2. A kilo is 10 to the 3. All right, so for practice here, 1 picogram equals how many grams? Everybody take a second. Pico, whoops. Yep, pico. P, 10 to the negative 12. That's how we would talk about stuff that's super duper tiny. Okay? So this is how we read our table here. So, what we really want to be able to do is to convert from, say, 47.3 centimeters. How do we convert that into meters? All right, that's what I mean by these metric prefix conversions. We're changing the prefix on our measurement. All right, so let's break this down into steps here. Again, metric. Conversions. This is going to be our example problem here. What did I say? 43.47.3. Okay. So, step 1, we got to find our relationship on that table. So in this case, I'm dealing with these prefix of centi, right? So that's that 10 to the negative 2. And I said that that means that 1 centimeter is equal to 10 to the negative 2 meters. All right? Now, when we're looking up on our table here. It's kind of easy to get confused about where the 10 to the negative 2 goes, all right? The one thing that we're going to chant to ourselves, that we're going to remember, is that the 1 goes with the prefix. The 1 is on the prefix side of this equality here. Okay? So the 1 goes with the prefix, all right? So when we look it up on our table here, again, we were looking up this centi. I get this 10 to the negative 2. I'm going to set up this equality here where the 1 is with the prefix and the 10 to the negative 2 is on the other side. Okay? So this is what we got when we looked it up on our table. 1 centimeter equals 10 to the negative 2 meters. Okay? Step 2, we're going to build our conversion factor by stacking one side of this equality on the other. So 1 centimeter over 10 to the negative 2 meters. And notice I am being really good and putting my units down there as well. Don't just have those numbers be naked. That's a great way to look back at your notes and have no idea what that corresponds to. All right. Now for every conversion factor, we can take it and we can flip it upside down as well. So 10 to the negative 2 meters over 1 centimeter. All right, and we can always do this for these conversion factors. I just take it and flip it. All right, which way I'm going to use, which one I'm going to use is going to depend on my problem. So the last step here is we're going to multiply in order to cancel our units. So what do I mean by that? I'm starting in these units of centimeters. I'm trying to jump to these units of meters. So I'm going to take my 47.3 centimeters and I'm going to multiply it by one of these two conversion factors. But which one am I going to pick? I'm going to pick the one that cancels out those units of centimeters and leaves me in the units that I want, the units of meters. So which one am I going to pick? The one on the left or the one on the right? The one on the right. All right, because when I take these and multiply them, I see that my units of centimeters will cancel out. All right, and remember with multiplication division, our units will carry. So these will cancel out because I'm dividing these. And then what happens to the meters? It stays, right? And that's my units of my answer. We're going to play this game over and over and over again throughout the course, performing these operations where we line things up in such a way that our units cancel. All right, that's the name of the game in a lot of the math that we do in the course. So be really good about setting it up on the page where you can see that your units cancels out. All right, a lot of people get really lazy and they just write something like this in their notes, 10 to the negative 2 over 1. That is a fantastic way to look back at those notes in a week and have no idea what that number is. It's like, where the hell did that come from, right? Be really good about putting your units down, 1, so your notes are more worthwhile, 2, so that you can see that your problem's actually set up correctly, okay? So then you're just going to punch it into your calculator, the 47.3 times the 10 to the negative 2, and we get 0.473. And what are my units? Those units that didn't cancel out, those units of meters. Cool. All right, we'll pick up and do a bunch more examples of this next class as well, all right? Again, we're using that constants page. I showed you where that lived at the beginning of class, right? That introduction page under our week 1 module.